In this lesson, we're going to look at another type of while loop, the event-controlled loop. The event-controlled loop looks for some occurrence, some event to occur to make the loop stop. There's several different types of event-controlled loops. We can't cover them all. Later in the chapter, I'm going to introduce you to files and working with files, and then we'll see an event where we read a file until we run out of data in the file, that being the event that stops the loop. For this particular lesson, though, I'm going to give you a simpler example where we're going to enter grades into a program until a certain grade called a sentinel value is entered. In this case, the sentinel will be -1. So let's get started. We're going to call this program whileEvent.py. And I'll explain how the sentinel works in just a minute. First, I need to set up a couple of variables. We're going to have an average variable, a total variable, and a count variable. So in other words, we're going to be entering grades until we get to a certain place where we want to stop. We're going to total those grades and then divide by the total number of grades to get an average. So we prompt the user to enter a grade and a -1 to quit. -1 is our sentinel value. Entering -1 is the event that causes the loop to stop. Then we get that grade in and we convert it to integer after we get it from raw input. Now we start our loop. While grade is not equal to -1, take the grade and add it to the total. Increment the count by 1 so we can keep an accurate number of grades that we've entered. And then prompt the user to enter a grade again. That's the end of our loop. So then when we're finished, we will compute the average by dividing the total by the count. And then we'll display the average grade. Just like so. So again, let's look at our event. The event is entering a -1 for the grade. So while a grade is not -1, then we can continue entering grades to figure out our average. So let's exit and save. And then let's run our program. So what we're going to do is we're going to enter a series of even values. Then we'll enter -1. And the average grade is 80. And that's right. Of those 5 grades, the average is indeed 80. Let's run it one more time with just a wide range of grades. I'll just keep entering for a bit longer. We'll do one more. So let's bring the program back up and let's review what we did. We have a loop that runs while the grade that's entered is not -1. And notice how we enter a grade initially before we go into the loop. I read once in a programming text that this is called priming the pump. So that we're priming the pump by assigning a grade here and then testing it here. And then we again enter a grade after we've taken the current grade, added it to the total, and added to our count. Going back to the original description of a while loop, we still have an event or a statement in the loop body that will cause the loop to quit. And that's this line right here, grade is equal to int raw input. Because once we enter -1, when we go back to the top of the loop to test our relational expression, grade is indeed -1, so that becomes false, that relational expression becomes false, and our loop stops. So that's how event-controlled loops work. And like I said, we're going to look at another example later in the chapter when we talk about processing text files. But for now, we're going to move to another topic, and we're going to talk about a special statement called continue that allows us to skip parts of a loop body and go on to the next iteration of the loop. In this lesson, we're going to demonstrate how to use the continue statement to cause a while loop to stop in the middle of executing the body and continue with the next iteration of the loop, which means just moving back to the top and testing the relational expression and then continuing back into the body of the loop. Let me show you the general form of the continue statement first, and then we'll look at an example. So we have our while loop and our relational expression. Then we could have some statements or not, Just depends on the situation. And then continue, and then more statements. So what happens is that usually continue will be based on some sort of condition. So if that condition is true and the continue statement appears, so let's put it in its context. If, I'm not saying this is the only way continue is used, but it frequently is. So let's go over the loop again. So we go into the loop, we execute some statements, then we test a relational expression. If that relational expression is true and the continue is executed, then control is transferred back to the top of the loop and the relational expression is tested again. If not, and then the other statements are executed and then control is transferred back to the top of the loop. So continue is used if a condition occurs that causes us to not want the remaining statements in the loop body to be executed. Let's look at an example of how that's going to work. So we're going to call this Python program continue. And what we're going to do is we're going to write a program that will take a numerator and a denominator and display the quotient. The numerator and the denominator will be set by the user. And we need a sentinel value here as to when to stop, so we're going to say -1. And that's just an arbitrary value chosen as a sentinel. The first thing we're going to do is prompt the user to enter a numerator, convert the input into floating point, just to be on the safe side. Then we'll ask the user to enter a denominator. Then we'll get the input from the user. Now here's where we'll provide our check. If the denominator is equal to 0, then we want to continue. Otherwise, we want to print the numerator divided by the denominator. And that's the whole of our program. And then we'll stop when the denominator is -1. So let's exit and save, and then run the program and see what we get. So we'll draw a simple one. 4 and 2 is 2.0. Notice that it displays it in floating point. Let's try another one. 34 and 13 is 2.615. Now let's try one with the 0. So we'll say 12 and 0. And notice what happened. We entered a 0 and it takes us right back to the top of the loop where it asks us to enter another numerator. So we'll enter another numerator and a denominator. Then we'll enter a numerator and a -1, and the program stops after it displays the result. So look at the program again. What we're trying to do is we're trying to find a particular condition, denominator equals 0, and avoiding it by not allowing it to actually display the result, which in most computer languages is an error. So by doing that, we just say continue, and then because denominator is not equal to -1, the program brings control back to the top and it asks us to enter a new numerator. So that's how the continue statement is used. Now we're ready to move to the next lesson where we're going to look at another way to change the flow of control of a while loop, and that's using the break statement to immediately exit a loop when a certain condition occurs. In this lesson, we're going to look at another means of prematurely transferring control in a while loop, and this time we're going to look at the break statement, which will cause a loop to terminate when the break statement is encountered. First, let's look at the general form of the break before we look at a specific example. So we have our while loop with the relational expression, and we have a series of statements. Then most likely we'll have a condition which, if true, will lead us to want to break out of the loop altogether. So we'll display it like that. And then more statements to execute, perhaps, if this relational expression is false. So again, what happens is that the loop executes normally unless this if statement or the relational expression of the if statement returns true, and then the break is executed and control is transferred to the first statement after the while loop. So we can put as a comment, break transfers control to here. And that's unlike the continue statement, which will send the control back to the top of the loop. Break takes you completely out of the loop. So let's look at a more specific example. We'll call this program break.py. What we're going to do is we're going to write the averaging program we wrote earlier. We're not going to worry about grades so much this time. We're just going to average some numbers. So I'll put a variable there, though I don't really need it this time. We'll set a total up. We'll set up an average. And then we'll also set up a count to keep track of how many numbers we're entering. So then we'll say while true. What's going to happen now is this loop is going to run continuously unless a sentinel value is entered, in which case we will then use break to stop the loop. So let's take a look at how that's going to work. So we prompt the user to enter a number. We'll get it in using raw input and convert it to float, so we can have floating point numbers if we choose to. Then we're going to say if number is equal to -1, break. Otherwise, add it to the total and increment the count by 1, and that will take us back to the top of the loop. And then when we're finished, we compute the average divided by the count, and then print the average. So again, what will happen is if the number we enter is -1, then control will transfer from inside the loop to the first statement after the loop, which is where the average is calculated. So let's exit and save, and let's give it a try here. Oops, I didn't do that right. Break.py, there we go. We have a little syntax error. So let's go back into the program. Our syntax error is right here. I left off this closing parenthesis for the whole print function. Very common to do when you're typing. I'm looking at this, as I'm typing this parenthesis, I'm seeing that parenthesis as the match, when of course that's the match for this parenthesis. So I need a second closing parenthesis to fix it up. There we go. Let's clear the screen. Try it again. That's much better. Let's do some very easy calculations. So here I enter -1. -1 triggers the break. So we break out of the loop and we compute the average. Let's run it one more time with just some random numbers. That's going to really mess our average up. That's going to mess it up even more. And so there's our average. So again, break can be used anytime some condition occurs that necessitates ending the loop at that point. I wouldn't recommend writing this program in the style I've used here. I just used this style for demonstration purposes. You are better off writing this program the way I did earlier in the chapter, but I wanted to demonstrate how break works with a familiar example. With that, we're ready to leave these topics of how to prematurely transfer control out of a loop and look at a very common use of loops in programming, and that's processing text files. And we'll cover working with text files in the next 2 lessons.